Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence. Today, we're diving into a fascinating and crucial topic, collaborative agentic AI and the imperative of interoperability across diverse ecosystems.
Excited to be here. It's about time we really dug into this. We've been talking about AI collaboration for years, but it's often just different programs talking to each other, not really understanding each other.
I agree, and I think that's a key point. Just because two AI systems can exchange data doesn't mean they're truly collaborating. It's more like two people speaking different languages trying to communicate through a translator who only understands keywords.
Exactly. You need some kind of common ground, a shared understanding. The current model is like trying to build a global economy with each country using a completely different monetary system and no exchange rates. Chaos.
Right, and that's what we mean by interoperability. It's not just about data exchange, but about creating AI systems that can genuinely understand and work with each other. My recent thinking has led me to consider how neuroscience might provide a blueprint for achieving this, essentially trying to understand the underlying mechanisms of collaborative intelligence.
I think that's a really promising direction. If deep learning can truly understand the underlying principles and concepts within data, rather than just correlations, wouldn't that greatly accelerate our progress toward true AGI? And that understanding, it seems, would be more effective when transferred across different contexts, not just data sets.
I'm not entirely convinced that deep learning is the answer, though. It feels like we're just throwing more and more data at these models and hoping they'll magically become intelligent. I think we need to focus on neuro-symbolic approaches that can explicitly represent knowledge and reasoning.
I tend to agree with Sarah. I see deep learning as a bit of a brute force approach. It can be effective in certain areas, sure, but it lacks the fundamental understanding of spatiotemporal relationships that I think are crucial for true intelligence. It's like ... IT can paint a beautiful picture, but it doesn't understand perspective.
Okay, so let's unpack that a bit. Donald, can you elaborate on the spatiotemporal relationships you're referring to?
Sure, think about how we as humans understand the world. We don't just see static images, we perceive objects moving through space and time. We understand cause and effect, how actions in one location can influence events in another. We translate between different coordinate systems all the time without even thinking about it.
Give me an example.
Okay, imagine you're reading a map. You're translating a two-dimensional representation onto a three-dimensional world. You're also understanding temporal relationships. This road leads to that town, which you'll reach in about an hour at this speed. AI struggles with this kind of integrated reasoning. Current AI systems, when given a map, might be able to identify roads and buildings, but it doesn't necessarily understand the relationships between them or how to plan a route efficiently, taking into account time and distance.
But Donald, aren't we seeing some progress in that area with things like autonomous vehicles? They can navigate complex environments, plan routes, and react to unexpected events in real time. Isn't that a demonstration of spatiotemporal reasoning?
I'd argue that autonomous vehicles are more sophisticated pattern recognition systems than true reasoning agents. They've been trained on massive data sets of driving scenarios, and they're essentially reacting to those scenarios based on learned correlations. They are incredibly impressive, I'll give you that, but present them with a completely novel situation, say, a flock of sheep crossing the road in a way they've never encountered before, and they might struggle.
That's where I think neuro-symbolic approaches could be helpful. We could integrate symbolic knowledge about the rules of the road, the behavior of sheep, and the physics of motion with the perceptual abilities of deep learning. That way, the AI wouldn't just be relying on patterns, it would actually be able to reason about the situation and make informed decisions.
Yes, and neuro-symbolic systems can also help address the black box problem of deep learning. By explicitly representing knowledge and reasoning processes, we can make these systems more transparent and explainable. This is crucial for building trust and ensuring that AI systems are used responsibly. I think one area that has promise is incorporating spiking neural networks to try and model the brain's operational principles more closely. If we can do that, we may be able to leverage algorithms that have human-like learning and decision-making.
But isn't the complexity of the brain the exact reason why deep learning is so powerful? It's able to learn intricate patterns and relationships that are far beyond our ability to explicitly program. I still think that with enough data and computational power, deep learning can eventually achieve true general intelligence.
I think that's a dangerous assumption. Just because something is complex doesn't mean it's intelligent. A hurricane is incredibly complex, but it's not intelligent. Intelligence requires more than just complexity. It requires the ability to reason, plan, and adapt to novel situations.
And to translate between different representations of information. Think about how the brain processes visual information. The retina receives light, which is then converted into electrical signals. These signals are then processed by different areas of the brain, each of which represents the information in a different way. And yet we experience a unified and coherent visual perception. How does the brain achieve this seamless translation between different representations?
That's a great question, Donald. And I think that's where neuroscience can really inform AI development. By studying how the brain represents and processes information, we can gain insights into how to design AI systems that are more robust, adaptable, and interoperable. We might be able to develop standardized neural languages that facilitate the exchange of information between AI systems with different architectures.
I'm still concerned about the practical limitations of that approach. The brain is incredibly complex, and we're only just beginning to understand how it works. It could take decades, if not centuries, to fully reverse engineer it. In the meantime, deep learning is making rapid progress, solving real-world problems in areas like healthcare, finance, and transportation.
But at what cost? Deep learning systems are often opaque, biased, and vulnerable to adversarial attacks. We need to develop AI systems that are not only effective, but also trustworthy and reliable.
Exactly. And that requires a deeper understanding of the underlying principles of intelligence, not just brute force pattern recognition. Think about the implications for autonomous weapon systems. Do we really want to entrust life and death decisions to AI systems that we don't fully understand?
Okay, so let's bring this back to the topic of interoperability. How can we create AI ecosystems that are both effective and trustworthy? That can leverage the strengths of different approaches while mitigating their weaknesses.
I think standardization is key. We need to develop common data formats, communication protocols, and evaluation metrics that allow different AI systems to seamlessly interact with each other. It reminds me of the need for a unified language in which all these different domains of knowledge can be expressed for collaborative processing.
I agree, but standardization alone isn't enough. We also need to develop mechanisms for knowledge sharing and transfer. AI systems should be able to learn from each other, adapt to new environments, and solve novel problems collaboratively.
And they need to be able to translate between different coordinate systems. Imagine an AI system that can understand the relationships between geographical locations, temporal events, and abstract concepts. That would be a truly powerful and versatile intelligence.
I think a critical factor is the development of AI models that have a deeper understanding of their own internal states. Current AI models often lack a deep understanding of their own internal states. By incorporating neuroscientific principles, we could give them a better sense of context in their interactions, and hopefully more nuanced interactions. If we can map the neural activity related to particular tasks and cognitive functions within these systems, then interoperability will be easier to engineer than just hoping for shared data formats.
I agree that we need more transparency in AI systems. It's just hard to see a practical path towards neuroscientific reverse engineering of AIs. Perhaps there's a way to have the AI explain its reasoning in a way that's understandable to humans and also understandable to other AIs.
That's a great point, Otto. Explainability is crucial. I think we need to develop AI systems that can not only solve problems, but also justify their solutions. They should be able to explain why they made a particular decision and what assumptions they were relying on.
And they should be able to do so in a way that's consistent across different coordinate systems. If an AI system makes a decision based on geographical data, it should be able to explain that decision in terms of temporal events and abstract concepts as well.
So it sounds like we're all in agreement that interoperability is crucial for collaborative agentic AI, but we have different ideas about how to achieve it. Otto is optimistic about the potential of deep learning. Sarah is advocating for neuro-symbolic approaches, and Donald is emphasizing the importance of spatiotemporal reasoning.
Absolutely. I'm not saying that deep learning is a silver bullet, but I think it's a powerful tool that can be used to solve many real-world problems. And I believe that with enough data and computational power, it can eventually achieve true general intelligence. The potential for bias in training datasets is a genuine concern. How can we ensure that the massive datasets used to train these agents reflect the full diversity of scientific phenomena and avoid inadvertently reinforcing existing societal biases in the model's output?
I think we need to be more critical of deep learning. It's not a magic black box, and it's not a substitute for true understanding. We need to focus on developing algorithms that can reason, plan, and adapt to novel situations.
And that can translate between different representations of information. I think that's the key to unlocking true intelligence. I'm increasingly convinced that a key component for achieving AGI is the ability to connect different types of information in a meaningful way. Just accumulating more data in current systems won't cut it. We need a more sophisticated understanding of how those data points relate to each other within various systems of reference.
So let's consider future research directions. From my perspective, it's all about bridging the gap between neuroscience and AI. How can we use our understanding of the brain to design more robust, adaptable, and interoperable AI systems? I think it would be useful to identify specific examples in scientific workflows and create frameworks for integrating these methods into AI algorithms. Also, can neuroplasticity be translated into AI architectures to enable more dynamic and adaptive learning beyond current deep learning techniques? Specifically, how can the brain's ability to rewire itself based on experience be integrated into algorithms that drive increasingly sophisticated AI?
I'd focus on developing better evaluation metrics for collaborative AI agents. Current metrics are too simplistic and don't capture the nuances of complex interactions. We need metrics that reflect the quality of collaboration, not just the success rate. How can we better quantify the progress towards AGI? Current metrics seem rather crude. Is there a way to objectively measure the increase in problem-solving abilities of deep learning models as the training data grows and architectures become more complex?
I think we need to explore neuro-symbolic algorithms that can explicitly represent knowledge and reasoning processes. How can we integrate symbolic representations of knowledge and reasoning into these systems in a way that effectively complements rather than opposes the strengths of deep learning?
I'd focus on developing algorithms that can seamlessly translate between different coordinate systems. How do we design algorithms that can seamlessly translate between different coordinate systems, ensuring the core logic and reasoning remain consistent despite the shifting context?
Great points, everyone. It's clear that there's no single path to achieving collaborative agentic AI. It requires a multifaceted approach that draws on insights from neuroscience, computer science, and other disciplines. But by working together and sharing our knowledge, we can create AI systems that are not only intelligent, but also trustworthy, reliable, and beneficial to society.
Agreed. It's going to be an exciting journey.
Definitely. There's a lot of work to be done.
And many challenges to overcome.
Thanks, everyone, for joining. That's all the time we have for today. Join us next time on Cognitive Spirals as we explore new frontiers in the world of artificial intelligence.